Hi, this is Lesson 72 in Algebra 2, and this lesson covers lines from experimental data and negative angles. All right, draw a line that seems to fit the data shown, then write the equation that expresses salt as a function of carbon. All right, so we've got two separate lines here, one that could go this way or one that could go that way. There is never an exact answer to these problems. The experimental data points are often scattered, and we can only estimate the position of the line. So you're not going to have an exact answer. Here we have drawn two lines, either of which might represent the relationship in the data. We've labeled the lines A and B. Line A appears to pass through points 140 and 10. So let's see, 140 would be here, and 10 is there, so about right here. Okay, and 60 and 1, so 60 and 1 about right there. So that's line A. And then line B seems to go through 40, 0. So about there. And 126, right about here. All right, so you have two separate lines that you could use for this data. All right, back to this. Really, all you have to do is pick a line, draw it, and then make an equation out of it, and you're not going to have an exact answer. Okay, on this one, rectangular coordinates can be changed to polar coordinates. All right, so we've got 4r plus 3u. Easy, so we're going to go to 4 to the right, 1, 2, 3, 4, up 3, 1, 2, 3, it's right there, okay, then we're going to draw a line from there to there, and figure out what that is. So this is 4, and this is 3, so we got to figure out what that is. A squared plus b squared equals c squared. This is actually a Pythagorean triplet. That one's going to be 5. Because 16, 9 equals 25. Square root of 25 is 5. All right, so that's 5. So to change that into a polar coordinate, we would say it's 5 long. And then we have to try to find this angle right here. Okay, so we would do that by saying SOHCAHTOA. Okay, and this is our angle theta. We could use any one of these since we've already found 5. So we could say sine equals opposite. Here's our opposite over hypotenuse, which is 5. And then we would just divide that and find the sine of that, which would be 36.87 degrees. So you'd write that as 36.87 degrees. Okay. Now, what this one is talking about is negative coordinates. So imagine that instead of us going from here and going up, we went backwards. So we made a line that went all the way from here to there. And this is going to be a negative coordinate because we went the other way. Instead of going counterclockwise, we went clockwise. So this is going to be 360 degrees is the whole circle minus our 36.87, and we're going to get negative 323.13. So the other way to write this exact coordinate would be 5 negative 323.13 degrees. So those two mean the exact same thing. All right, write 4, negative 210 in rectangular coordinates. All right, so we got to figure out where that point is. Okay, so 4 means we're coming out 4. And negative 210 degrees. So we're going to start here and we're going to go around. So that would be 90. And that would be another 90. So that's going to get us that 180. And we need to get to 210. So we're going to go up just a little bit more. Okay, so we're going to be around here somewhere. And 4 out is going to be pretty far. Oops, let me erase that. So we're going to be somewhere over here. Okay. Now, how many degrees would this be? Well, if we've got 90, and that makes 180, and we get going to 210, $30 degrees. So now our angle right here that we're going to try to find out is 30 degrees. Okay, and we just make that into a triangle, and we know that this is 4. All right, so we can use trig functions to figure that out. So here's our opposite. Here's our hypotenuse. Let's see, so sine of 30 degrees equals our opposite over our hypotenuse, which is 4. So you multiply times 4 and times 4. And that gets us 2. So you do that on a calculator, find your trig function. So the opposite is going to be 2. Okay, and then, so that'll be A. Here's B, down here. So we would say the sine of 30 degrees. And for this one, actually, we're going to use cosine. So TOA. So cosine of 30 degrees equals adjacent over the hypotenuse. Adjacent, we don't know. That's down here. Those are adjacent. Our hypotenuse is 4. So then we multiply times 4 and times 4. So we find the cosine of 30 degrees and multiply that times 4. And that actually comes out to 3.46. Okay, so to turn this into rectangular coordinates, we went negative 3.46 to the right, and then positive 2 up. And there's our rectangular coordinate for this that used the negative sign there. All right. Go ahead and work the practice problems, and then I'll come back and work them for you. All right, write a rectangular coordinates. Write that in rectangular coordinates. So if we just make a little that guy, and we got to get to 230. So that's 90. That's 180. 230 minus 180. 50 degrees. So we're going to end up going up 50 degrees right here. Going to be like that. And there's our triangle. Okay. And then we know that that angle right there is 50. Okay. And then 5 is that part. Our hypotenuse is 5. So we're going to use sine of 50 degrees equals, which will be the opposite. Opposite is here. And there is our adjacent. Opposite over hypotenuse, which is 5. So we would do times 5 times 5. So we need the sine of 50 times 5. And that is going to be, let me find a calculator here. calculator.com. Okay, we need a scientific calculator. Okay, and then we need the sine of 50 degrees times 5. And we get, nope, doing that wrong. We need to make sure that's in degrees. So 50, clear everything. 50 sine of 50 degrees times 5, 3.83. Okay, so that means that this one is 3.83. That's our O. Okay, and now our adjacent, we're going to use the cosine. Cosine equals of 50 degrees equals adjacent over hypotenuse, which is 5. So we multiply times 5. So we need the cosine of 50 degrees times 5. Clear all that. 50 cosine times 5 equals 3.21. So that means our adjacent down here is 3.21. So to change that into rectangular coordinates, we went to the right, negative 3.21 to the right, and then we went positive 3.83 up. So there's our rectangular coordinates for that polar coordinate with a negative. All right, this next one, you're not going to get the same answer that's in the answer key. It asks us to draw a line. Estimate the location of the line indicated by the data point. So if I started like right down here, oops, I don't need it to be that kind of line. I need a straight line. All right, I could get one that went like that, approximately. That hit some of them. I could put it here. I could put it down there. I'm just going to put it somewhere in the middle there. Looks pretty good. All right, so 2 points that I could pick out here. That, and someplace else where it looks like it's almost touching, maybe right there. Okay, so I'm going to have my coordinates of, see, this is 100, 102, that means this is 101, so that'll be 99. And let's see. Okay, so I've got coordinates of 99, and my y would be 80. Okay, and then I've got a coordinate of 102 and 100. Okay, so I'm going to use h equals mc plus b. Okay, so b is my one that I'm going to have to find. M is the slope, so I went, and that's going to be rise over run. Okay, so I went from here to there. My run would be 1, 2, 3. My rise would be, I went from 80 to 100, so 20. 20 over divided by 3. .67, we're going to say. So h equals 6.67 c plus b. Now I'm going to fill in my h. I'm going to pick one of these values. I'm going to go with this one. So h would be my up and down, which is 100. 6.67 times c, which is 102, plus b. So I need 102 plus 6.67. That looks like a 4. That's supposed to be a 7. There we go. No, times. So I'm going to go to my calculator. 6.67 times 102. 680. So we're going to have 180 equals 680 plus b. So now we're going to do minus 680. That would be 500. I don't think that could be right. Because that's where it crosses the y line. Yeah, I've got something mixed up here. Okay. Let's try this again. Okay, let me make sure I got my points right. Okay, so if I've got 90, that would be 80, and that's 99. Okay, and then I've got 102 and 100. Okay, so I went from 99 to 102. 1, 2, 3. And then I went up from 80 to 90 to 100. That'd be 20. Okay, so that's my M. And that was 6.6 or something like that. I'm going to round that to 7. And I'm going to say H equals 7C plus B. Okay, now my H is going to be, I'm going to use this one. My hydrogen value for this one is, let's go with this point right here. My hydrogen value is 100. Actually, let's try this one. It didn't work last time. My hydrogen value would be 80. 7 times my carbon value would be 99 plus B. Okay, so now I need 7 times 99. 693. Minus 80. 613. Okay. So I think that I've got my line off a little bit, but either way, the book's answer, so my answer would be, what was that? 613. My answer would be H equals 7C plus, no, minus. Or something like that. The book's answer is H equals 3.88C. So their slope was a lot different than mine. Minus 753.33. Let's do a little bit better. So as long as you got something around there, something that looks similar to that, then that's fine. Those I cannot grade as being exact. All right, so it's just an estimate of what that line would look like. All right, and that is it for lesson 72.